To simplify or multiply what are called rational expressions. First of all, a rational expression is a fraction. The root word in there, those of you people who like English, root word is ratio, so fraction. So we have fractions multiplied together or divided. To work those out, we need to be able to factor. Now, at this point in college algebra, if you can't factor, I don't have time to teach you that right now. You either need to come see me or get really good at your calculator. Why do I say really good at your calculator? Go to programs in your calculator if you have one that I've put programs on. What's a program that sounds useful? Factor Poly. Good idea. So you either need to use that or come see me, because at this point, if you can't factor, you have learned how to factor in Algebra 1, you learned how to factor in Algebra 2, you learned how to factor in here. So if you still can't factor, today I can't fix that. You know what I mean? Like, I don't have time today to fix that. So if you are still struggling with factoring, you have either got to come see me and work through that, or get really good at your calculator, one of the two. Okay? X squared minus 16. How do you factor x squared minus 16? Difference of perfect squares. Good. So, very good. Very good. Did everyone find a factor poly program on their calculator for those of you who don't remember how to factor? Did everyone find that? Did anyone not have that? So stop by for a second after class and I'll download it. It will factor polynomials for you. What about this one? What do I do on x squared plus x minus 90? What do I ask myself? Good. What are the factors of 90 that subtract to give you 1? And what? Good. 10 and 9. X plus 10, x minus 9. And what about the factors of 40 that add to give you 14? Very good. Now, I could multiply across the top and multiply across the bottom, but ultimately I want to simplify this. What do you know? Say you have a 3 divided by 3. What is 3 divided by 3? Just 1. So if there's anything on top that corresponds with something on the bottom, I can cancel it out and it gives me 1. So do you see anything that I can cancel out? X plus 10. In order to cancel anything out, you have to be in factored form. One of the most common mistakes is people trying to X out these x squareds. You can't do that. You can't do it when it's addition, because 1 plus 4 over 2 plus 4 is not the same as a half. Everyone know what I mean by that? It's not, you can't just cancel out things that are added, but multiplication you can. Anything else you see? The x plus 4. Anything else? Almost, right? X minus 9 and 9 minus x? Is there any way that I could make that work? Could I have factored out a negative 1 out of this piece here if I wanted to? So if they are a subtraction problem that's just written backwards, you can factor out a negative 1. Is negative 9 plus x the same as x minus 9? So now I can cancel that one too. So I only end up with x minus 4 divided by negative 1, which is negative x plus 4. Would you agree that is much simpler than that big messy thing we had up there to begin with? I divided by -1. No, wait, sorry. Plus x. Sorry, I was looking down here. Yeah, I factored out a -1, and so it changes the sign on both.
So you can cancel it. It's like the opposite, like +9 or -9.
Not if you leave it like that. But now that I factored this out, this is now -9 plus x. So that's the same as x minus 9. So I did have to factor out that negative to make that happen. Okay, let's look at the next one. The first one was multiplication. This one is what? Division. So does anyone from Algebra 2 remember how to divide two fractions, or from Algebra 1? Times what? Hold on. Yes. I do. Okay. Not, I mean, maybe. It depends on how you're thinking of it. We will. Okay, time out. Don't do anything first. I want to know, how do you divide two fractions? Very good. You multiply by the reciprocal. What in the world does that mean? Flip the second fraction. So step 1, I'm going to flip the second fraction. And Kyle, if you were doing that first, then yes, you can cancel those out. But if they were both on the bottom, you couldn't. One has to be on top and one has to be on bottom. So it depends on how far ahead you were thinking. If you were flipping them, then yes.
Okay, so why not flip the...
That's not how you divide two fractions. You flip the second one. It does. And so now it's a problem like the one before. I always want to do that first, because if you don't, you will forget to flip. So flip anytime you see divide, the first thing you do. In fact, if you're doing it on your homework, you might not ever write it down on your paper as a division problem. You may just flip it and write it down as multiplication to begin with on your homework. Does that make sense? Okay, now I'm going to factor. 2b squared minus 12b. Does anything factor? 2b. Does everyone agree I can take out a 2b? A greatest common factor. Remember, step 1 in factoring is to take out a greatest common factor. You will occasionally come to things your calculator won't want to factor. That's not one of them. As long as you put an x there, it would, for b, it would factor that for you. Now what? Anything on top that cancels with anything on bottom. Remember, it has to be one on top, one on bottom, because we're dividing to get 1. And so I'm just left with 2b.
Okay, so what if we get factor? Let's say that...
Then it couldn't cancel with anything except that whole piece. Like, say the 2b squared minus 12b didn't factor, then the only way you could cancel it with anything would be...
So you want to...
At the end, if there's anything left on top, you'd multiply across the top. But if nothing canceled with it is a factor of its own, then you just couldn't cancel. What is step 1? Flip which one? Second one. Again, do that first. If you don't, you might forget. Do y'all remember doing this last year?
Yes.
Yes, no?
You can take
Good. Let me slow down for a second. Any questions first on the flip? And then I'm going to factor. Remember, step one, always look for a greatest common factor first. Does everyone remember what a greatest common factor is? The biggest number or letters that goes into both pieces, or all pieces. 5p squared is already factored by, it's already, remember, factoring is writing as multiplication. 5 times p squared is already factored. So I can take out a 5p squared in the top. I would be left with p minus 7. Does everyone agree with that? Yes, no, maybe? On the bottom, what can I factor out? What cancels? 5p squareds. Notice I do have things left on the top and on the bottom. I'm going to multiply across the top and multiply across the bottom, and I get p minus 7 over 9 times p minus 4. You also could write 9p minus 36 on the bottom if you wanted to. I'm always going to leave it factored because that's more useful for things we will do later in chapter 8, or chapter 7.
Oh,
We're doing 6 first, but there will be some things in chapter 7 that are easier if you leave it factored. Yep, that's it. We're almost done. Okay, I've got 2 more examples here, and then we'll do some addition of fractions. I can. You're welcome. Do I need to flip this one?
no.
Why not? It's multiplication. So what do I do at the beginning? Factor and start with GCFs if that is an option. Remember, if you get stuck on factoring, use the factor poly program in your calculator. Don't not factor it. Do I need to remind you what that looks like? Factor poly? Just a quick reminder. Oops. Program. On my programs, it's number 2. Yours may be different, but it's factor poly 2. You put the degree. You had to know that for your homework. What is the degree of a polynomial? The highest exponent. Good. So we have talked about that before when we learned how to use it's the highest exponent. So on this, it's the number next to the highest exponent. But again, flip back 2 pages. 1 page or 2 pages, and your textbook will tell you that. Okay, so I'm going to do this bottom one, 40x cubed minus 80x squared. X cubed is the highest power, so 3 is the degree. What is the coefficient of x cubed? 40. What is the coefficient of x squared? Negative 80. Everyone agree? What is the coefficient of x? 0. Why 0? There's not an x. And what is the coefficient of the constant, or what is the constant? That's the number with no x's by it. 0. There's not one. And it factored it for me, 40x squared times x minus 2. Everyone see how that works? Now, I would argue this particular problem took me way longer to pull my calculator up but if you had one that you came to that was more challenging than a GCF, then you might want to pull your calculator up. 10x times x minus 2, 40x squared times x minus 2. And you saw where my calculator gave me that, right? It will do that for you. And on top, 16 factors out 16x squared, is that right? And how many times does 16 go into 80? Okay.
So,
What else? You see anything else? Okay, so at this point, I'm going to pretend I don't see anything else. I do, but I'm going to pretend I don't. Yes. Okay, x squared.
Yeah.
Okay.
Or you can do that with a number. Like if it's just
Is it 16 times x squared?
oh.
So the x squareds can cancel. So now I have 10 times x times 16 on the top. Now I will multiply those together if I end up needing to. And 40 times 6 on the bottom. I'm going to wait to multiply them together until I've decided for sure that I'm done reducing, because it's harder to reduce once you've multiplied everything together. Let's look at the numbers. 10 and 40. Would you agree those can simplify? Down to what? 1/4? Yeah, 1/4. Okay, so I'm going to go ahead and do that part. So I have 1 times x times 16 over 4 times 6. You could, but I'm not going to yet. You could, and then it'd still simplify. But what about 16 over 4?
Could you do that?
Yeah.
You could. You could. Either way. What about 16 and 4? 1/4. Well, 4 over 1. Will your calculator reduce numbers for you as well? So now I've gone ahead and multiplied everything I have left. I have 4 over 6. And I still have an x on the top. Remember, you could, and you could have done this. Someone said earlier, could I go ahead and multiply and make this 160 over 240? You could. If you type 160 divided by 240, math enter, enter, do that for me really quick. 160 divided by 240 in your calculator. What do you get? Math enter, enter to make it a fraction. 2/3. So either way, we did it by hand, all the way by hand. Okay, any questions? Okay, let's look at the next one. Flip it first. Some of you can handle flipping and factoring at the same time. I am fine with that if you can, but make sure you flip first. Don't forget to flip. Factor. And now what? First glance, it appears that nothing cancels. Yes. So first glance, it looks like nothing cancels. Okay, 6 minus n and n minus 6 are awfully close. So I'm going to factor out a -1 out of the 6 minus n. Aren't we used to seeing the n being positive? So I'm just going to pick that one. Then those can cancel. That does leave me with a -1 on the bottom. So I have 3 on the top, -1 times n plus 9 on the bottom. Or you could do -n minus 9 if you would like. So that is how you multiply and divide fractions with letters in them. Any questions about that? So do we remember doing that in Algebra 2? A little bit. Alright, now we're going to combine fractions. I have a little reminder there, mastery exams due Friday, February 26th. I'm not sure why it's there and not on the front page. Before we do fractions with letters in them, we're going to start with fractions with numbers in them. I am not going to pick up my calculator, not because you can't, but because in just a second we're going to put letters in it, and then our calculators are in trouble. So I want to know how to add and subtract fractions. What do you have to do? Get the denominator to be the same. Everyone heard of that before?
Yeah.
So I need the denominator to be the same. This is really corny, and I apologize in advance, but it'll help you remember it. We want to be the cool kid. Everybody wants the same denominator. It's like junior high. We all want to be the same. Again, you'll get over the corniness. It'll help you remember how to do it. So the 2 wants to be like the 3, and the 3 wants to be like the 2, the 8 wants to be like the 2, 8 wants to be like the 3. They all want to be alike. Well, to know how to be alike something, you have to know what it's made up of. So the first thing I would do is factor. I know if this were numbers, you could probably just do it in your head. But I'm going to pretend because we're about to do letters. 8. Does it have factors? What are they? 2 and 4. And if I go all the way down on a factor tree, 2, 2, and 2. Does everyone agree with that? So it has 3 2s. It must be really cool. Must be a really cool kid in junior high. Again, you'll get over it. Okay, so it has 3 2s. Does it need a 2 to be cool? No, it has 3 of them already. It has more than anybody else. What does it need to be like? What is it missing? What does it want? The 3. So I'm going to put a 3 on top and bottom. Why would I put it on top and bottom? Whatever I do to the bottom, I have to do the top, otherwise I change its personality, right? I change its who it is. So I have to multiply by the 3 on top and bottom. What does the 3 need? It needs 2, 2, and 2, right? It needs all 3 of the 2s. Everyone agree? Or you could say it needs an 8, but we'll go with needs a 2, 2, and a 2. Just for room, I'm just going to put times 8 because I don't have room to put 3 2s. And what does the 2 need? It needs a 3. Does it need the whole 8?
No, it just needs 2 2s.
It just needs 2 2s. Why does it only need 2 2s? Because it has a 2 already. But to be like the 8, it needs 3 2s. So evidently the cool kid in this junior high school is 3 2s and a 3. Right? That's the common denominator. So I have 2 times 2 times 3, which is 12, over the bottom, which is 24, if you multiply all of that out. So the common denominator was 24. 8 over 24. And, oh, that's a minus.
Can't you just like look at that?
For numbers you can, but remember we're about to go to letters. So we need to learn how and what's how it's working. Because with letters, you're not going to be able to just go, oh, it should be a 24. But where this example was a little bit really for you, because I figure you probably could add those. Add across the top. If there's subtraction, then you subtract. So 20 minus 9, 11 24ths. Notice you leave the bottom alone. You don't do 3 24s. You don't add those. You don't add then subtract. You just leave the denominator alone. So that's how you add regular fractions. The point of that was so that we could add these. Okay. So we have a little bit of work ahead of us. Remember, I can only change fractions by multiplying them, so we'll keep that in mind. The first fraction, what do you notice about all of those denominators? They are already the same. Do I have to do any work if they're already the same? So what do? I just add and subtract across the top. Anytime there is subtraction, distribute it to anything on the top of the fraction that is subtracted. So 8x plus 7x minus 7x, would you agree that's 8x? And then the negative 2 all over x plus 5. So if the denominator is already the same, it's as simple as that. Obviously, they won't all be that easy. So let's look at the next one. Yep.
You were just looking at
So the bottoms are the same. Because of that, I can add across the top. So I'm essentially ignoring that the denominator existed and combining like terms on the top. If that makes sense. Okay, let's look at the next one. Remember, the only way I can change it is by multiplying by something. Is there any way I can multiply by something to make x plus 10 any different? To make it like x. These are just different guys, right? So, what does the left-hand fraction need to be cool? It needs x minus 10. It needs that whole denominator on the right. Because they aren't, even though they kind of look similar, they're not the same factor. They're not the same thing. So the one on the left needs an x minus 10. If I do that to the bottom, I have to do it to the top. The one on the right needs an x plus 10. To be the cool kid. Again, I know that's corny. You will forgive me eventually. Remember, be careful with negatives. I'm going to move that negative up here beside the 10 so that I remember to distribute it to everything on the top. So, on the top on the left, I get 10x minus 100. On the top on the right, I get negative 10x minus 100. Remember that negative distributes in to everything on the top. Divided by the bottom, and I'm going to leave that in factored form just because I'm lazy and there's no reason not to. You could FOIL it, it would be correct, but it would be unnecessary. So just leave it in factored form. On the top, can I combine some things? What can be combined together? The negative 100 minus 100 is negative 200. What about the tens? Positive 10x, negative 10x. Cancels, gives you 0. So it's negative 200 over x minus 10 and x plus 10. I'm going to do all of these examples eventually, but I do want to do one that I have to factor first. So I'm going to skip down to this M, the one with the M's in it. Let's do that one next. Okay, remember I can only multiply to make the denominators the same. I have no idea what to multiply by to make them the same because I don't know what they're made up of. Remember on the 8 how I decided to look at the factors of 8? And they were 2, 2, and 2? Do these two things factor? Let's factor them. So m minus 1 over, so is it very, very important that you can factor? So if you struggle with that at all, get factor poly from me before you leave today, because you will need that to be able to do these. M plus 8 and m plus 4. Does everyone agree with that? Factors of 32 that add to give you 12. And the right-hand side is m plus 2 and m plus 4. Remember, we are adding, not multiplying and dividing, so the goal is a common denominator. It was important to see what those were made up of because what you already notice is they already both have an m plus 4, so they don't need that part. That part of them is already cool. But what does the left-hand fraction need that it doesn't have? M plus 2. So, I think will work. I need to multiply by m plus 2 on the top and bottom. The right-hand fraction needs what? M plus 8.
I have a question.
Mm-hmm.
Can you just multiply m plus 2 times 4?
No, because then you would get 2m plus 8. Does that make sense?
Yes.
Good question.
So you just do the opposite. So like one would be you just
Whatever it's missing. Remember, we need to, the denominators want to be just alike. So I look at this denominator and notice it has an m plus 2 and this one doesn't. And so it needs it. On the top, I'm going to FOIL that. M squared minus m plus 2m minus 2. So that's the left-hand top. The right-hand top, I'll switch colors so you know I'm switching, is 5m squared plus 40m. Are you taking notes? Minus 4m minus 32. Remember, the denominators are the same, right? So now I can just write one denominator. It's m plus 8, m plus 4, m plus 2. It has all the pieces. What do I do on the top? Combine like terms. So the m squareds make 6m squared. The m's, we have a negative m, a positive 2m, a 40m, and a negative 4m. I'm going to combine all of those together. So I get m here. So 41 minus 4 is 37m. then the last one is all the constants. The 2 and the negative 32. Negative 2 and negative 32 makes negative 34. I'm going to leave the bottom alone. Again, if there was anything I was going to do to the bottom, it would want to be in factored form anyway, so I'm going to leave it in factored form. You could throw that numerator in factor poly and see if it factors and see if anything simplifies. You could also do that. It is a pretty yucky factoring problem, so I will spare you for today. But you could throw it in factor poly and see if it factored. Okay, any questions about that one?
How did you get 6x?
The m squared, the underlined blue. Stop. Alright, tomorrow I will do a few more examples. Listen, quiet, quiet. Tomorrow I will do a few more examples of adding and subtracting. And then I'm also going to show you how to do long division. So there's a couple more things I'm going to show you there. And then we're also going to start chapter 6 tomorrow. Monday we will have a day to pick up anything we've left off on those two things. Any questions?